So we'll be starting with this new topic, that is the materials used in 3D printing. This will be your chapter number 4. So let's begin. So these are all the contents which we'll be covering in the materials used. So we'll study about the polymers, different types of metals, non-metallic materials, ceramic materials, composite materials, all the different types of materials which we'll be using in 3D printing. Then finally, we are going to study about the support materials which we'll be using in 3D printing. So let's begin. So first, we'll study about what do you mean by isotropic and anisotropic materials. So let's begin. This is some chemistry involved. So before proceeding to the actual topic, we'll be studying about these two topics. It's a short topic. So isotropic materials are the materials whose properties remains same in all the directions, and anisotropic materials whose properties varies depending upon the direction. So for example, if I have any material, if I bend in one direction, change the direction and bend it again, if its properties remains the same, those are isotropic materials. And if depending upon varying, like if I'm using a material whose bending operation is different, compression operation, if I'm doing the compression or I'm pulling it outwards, if it is the properties are varying, then those are called as anisotropic materials. Now moving towards the example, isotropic materials. So moving towards the example of isotropic and anisotropic material. So here are the few examples like plastic, glass, metal, diamond comes under isotropic materials whose properties are same from every direction if you take. Anisotropic materials are the materials whose properties change depending upon the direction. So the examples are wood, slate, ice, tourmaline. So considering the wood, I'll give an example. So if you consider a baseball bat or a cricket bat which is made up of wood. So in case of a baseball bat, if you want to hit a perfect shot or a home run, you have to hit the ball should be at the center of the bat. So perfectly at the center of the bat, then only it will hit the run. But if you have seen in few of the cases where the bat completely breaks, so if the ball hits at the particular edge or the angle of the bat completely breaks. Same happens with the cricket bat. If at the edge the ball hits, the bat completely breaks. So anisotropic materials, you can see wood changes its property if it is hit at a particular direction or an angle. Even the most common example of an isotropic material is the carbon fiber. So carbon fiber, as you can see here in the image, it is made up of numerous strands of carbon. So the carbon strands, the fibers, the property of the carbon fiber is that if you are using in any car or any other material, it is used for stretching. Okay, so if we stretch the carbon fiber, its strength is very huge. It is very strength in stretching. But if you are using a carbon fiber where we are bending operation is there. So whenever the bending operation is there, carbon fiber is very weak. So we are always using carbon fiber where we are using a stretching operation. So this is so as you can see, the carbon fiber material changes, the properties changes with the change in the direction or the angle. So before moving forward, I'll give one more example of an isotropic material. So this is the object which we have printed, 3D printed. So as you know, this object is printed layer by layer. So now you know that this object is printed layer by layer. So its strength is in this direction. So if I keep an heavy object on this, so it will bear the strength. Okay. But on the other hand, if I keep the object like this, and as you know, the layers now are like this, so there will be, might be the strength is not much more in this direction. So if I keep any object here, so there are chances it will break from this point. So this is an isotropic material, the PLA material which we are using. So its properties are changing with change in the direction. Okay. So moving forward. So this is the first topic or the definition which we'll be studying now. That is define plastics or polymers. So you know there are monomers and polymers. So monomers have molecules distributed, very small molecules distributed, and polymers on the other hand, it has a one large chain of molecules. So the actual definition, polymers are the materials made of long repeating chains of molecules. The materials have unique properties depending upon the type of the molecules being bonded and how they are bonded. Okay, so the chain of materials, the bonding is strong in polymers. Next, there are the few properties of polymers. So first is the high strength. So polymer materials have excessive strength in them. So the object which you make, so this 3D object. So there are different types of polymers also, like PLA, ABS. This is made using PLA material. So it is quite tough, but you have different types of polymers also, which are more tougher than PLA. Then low density, so the weight, if you compare the weight of this object or the other object made, this is quite low in weight, so it is low density. Flexibility, the objects can be made which are flexible. Thermal and electrical insulation, it has electrical the properties, it has thermal capability and electrical insulation is there. Next, the point is repeated. It is resistant to chemical. So any chemical is there, it will be resistant to that. Most of the chemicals used are resistant to the chemical. Then water resistance, obviously I can put this in water. Nothing will happen. It is water resistant. Biodegradability. So this is the most important point I want to highlight here. So as you know, the polymers are plastic, but this plastic material, again, this PLA material, plastic material, this is biodegradable. Okay, so it is eco-friendly. It is made from like sugarcane material, corn and sugarcane material. So this is biodegradable. So it doesn't harm the environment. Moving forward, more properties, transparency, you can make the object which are totally transparent. There are materials which will be totally transparent. The adhesion, so the bonding properties are very good. So as you can see, it is completely intact. The layers are quite smooth. You can't even see the layers. So adhesion or the bonding property is very good. It can be easily processable. So the post processing or the coloring, anything is done beautifully. I'll show you some things which are like processing is done. So here only you can see the colors and everything are well into it. So you can put colors, it's really good. Moving to the next topic, that is the different materials which are used in 3D printing. First is thermoplastic. So this is the basic material which is used in 3D printing. Most of the 3D printers use this material. So those are ABS, PLA, PETG, nylon. So this all comes under thermoplastic materials. So can be modified, can be printed, molded easily. So here it is written can be molded easily. Then the ABS material will learn this, the full form and everything detail in further. So this material, as I already told, this is the PLA material, PLA materials. And ABS material, it is much stronger than PLA. So obviously the PLA material, the melting temperature of this PLA material is around 200 degrees Celsius, while ABS it is around 250 degrees Celsius. But there are environmental conditions also included. So these are the different thermoplastics. Next, we have photopolymers. So as the name suggests, photo. Whenever we get this name photo, so it is related to light. So photopolymers are the materials which are used in SLA, that is stereolithography, digital light processing. So wherever the light is involved, the materials are used. So here you can see you have this material. So this is the liquid resin material and the laser comes from top and it solidifies and slowly this object is coming upward. So these are all the supports here. So this is the 3D printing process where we are using laser or the UV light. So those are photopolymers. So resin material is used. Next, metals. So as you can see, different metals like aluminium, stainless steel, titanium, everything can be printed with 3D printing. So you can say the whole engine is also here. You can see the entire engine is also printed with using 3D printing. So the biggest advantage is that in traditional printing, or if traditionally if you want to make this engine, so you have to make a cast, you have to pour the molten metal liquid into the cast and then it will be generated. So, but the disadvantage over there is if you want to make minute change in this metal, if you want to make the minute change in this engine, so you have to change the entire cast or the mold of the engine. Whereas in 3D printing, just you can change it in your CAD file and it is done and it will be printed. The time taken is obviously more, but it is very friendly. You can change it easily. So titanium, stainless steel, aluminium are the metals which can be used. Moving forward to the ceramics, so porcelain, glass. Here you can see the pottery can be done using 3D printing. The glass can be printed. So it is flexible, transparent material is used over here. Pottery, everything can be printed. Composites. What do you mean by composite materials? Composite material are basically alloys. So two or more materials which are combined can be called as composite materials. So metal, steel can be combined with other carbon fiber. You can get beautiful materials. So the combination of different materials. For example, you have carbon fiber, Kevlar, the jackets which military people are using. So those are Kevlar. So carbon fiber is the best example of the composite materials. So this is made using carbon fiber. So you can see 90% of the carbon fibers are produced from polyacrylonite, that is PAN, and the remaining 1% is used by Renon or petroleum pitch. So remaining 10% is used from the Renon or the petroleum pitch. So this is how carbon fiber is made. Moving forward, you have biomaterials. As you know, the health industry is growing so immensely fast. So in healthcare industry, we require different human parts like ears, nose, even the heart and the lungs and the tissues, everything is getting 3D printed. So cells, tissues, biological materials, every can be 3D printed. So there is no need of transplanting from other human to other human. You can easily print and you can use it. So good. More wax materials create molds for casting metal objects are used. Food materials, food industry is also growing so immensely with this. So you can shape according to the chocolate molds. We are using molds nowadays, but wastage is there. But here you can directly design anything you want. The sugar dough, chocolate, anything with food industry is also using 3D printing so immensely. So next interesting type of material which is used in 3D printing is paper. So yes, paper is also used as a material for 3D printing. So generally you know that for paper we are like it is generally used for 2D printing, but for 3D printing it is also used. These are the few you can see this model is made using paper. So basically how it is done, you have an inkjet printer is only used inside the 3D printer. So each layer of paper, first sheet of paper, then it is colored using inkjet printer. Then the paper is cut according to the shape. So you can see it is cut according to the shape. Then the next layer of sheet is pasted on the previous layer. Then again it is colored, it is cut. So coloring, cutting and pasting, this is the process how the paper is used in 3D printer. So very accurate dimensions you can get using a paper as a 3D printer. So it is a totally different type of paper. A roll paper, normal paper is used. The entire roll of paper is used and it is cut. Again, the part which is cut off, it can again be recycled and it can be used. So paper is recycled and it can be again used. So minimal wastage of material is therein while using this paper 3D printer. Okay, so this was all about our materials used in 3D printing. So we'll discuss this type of the basic material, that is the PLA material. It is also called as polylactide. So this is the widely most popular material which is used in 3D printing. It is available in abundance and it can be recycled. It is biodegradable, eco-friendly. So this material is widely used. It is different types of colors can also be implemented in this type of PLA material. So PLA is basically a plastic type of material, but it is biodegradable. So please keep that in mind. So PLA is a commonly used thermoplastic material in 3D printing. It is biodegradable and it is compostable material made from renewable source like corn, starch and sugarcane. So due to which it is biodegradable. So you can see here some colors. This is the blue color of, so you can white, blue, copper, any type of color can be implemented in PLA. Next, we'll see for some of the uses of PLA. So it is used for prototyping. Prototyping is basically a model. If you want to construct a building, the creating a prototype small model is called as prototyping. So before creating an entire object, you create a model, that is called as prototyping. Next is artistic applications. So any again you can print like you can design in the CAD file, you can print the objects. That is nothing but the artistic applications. Educational purpose, there are n numbers of things you can do it in education. This is again one example. Toys and figurines, so small toys you can make using 3D printing, simple, you can easily duplicate. You can make accurate toys models, always. Household items, any holder or kitchen knife holder, anything you can make. Uh, Possibilities are limitless. Next is cosplay and props. So as you have seen in many Comic Cons and everything, you have people who are wearing the entire suit of their superheroes. So that suit is also totally printed in can be printed in 3D printing. So you can again, as it is not conductive, so you can apply electronic equipments. You can put electronic equipments. You can make it work. Everything. So many endless possibilities are there in cosplay and props also. Then medical models are made, packaging and containers, aerospace foils, the wings, everything can be designed using 3D printer. The use of different materials. We have seen this explanation in previous topics also, where aerospace, the nozzle, it is made up of two different types of materials. So that can be easily made using 3D printing. The design is of sustainable, it lasts long. So it is. So these are the few uses of PLA. Next, we'll go for the types of PLA. So as you know, we have just seen the standard PLA. So the standard PLA temperature melting point is around 200 degrees Celsius. So we can put some extra things, like we can modify the PLA and we can use for high temperature PLA. Tough PLA, you can make it tough. Flexibility you can increase, so that is the flexible PLA. You can use conductive PLA, you can make conductive PLA, glow in the dark PLA, wood filled PLA, metal filled, carbon fiber, and color changing PLA. So these are the few types of PLA uh, materials. So you can make the changes and you can go for that. So this high temperature PLA around 250 degrees Celsius, it can go around. So according to your applications or need, you have to select the right type of PLA which you want. So mostly the standard PLA, we make everything in the standard PLA, but according to the applications, you have to do the changes. Advantages of PLA. So here are the few advantages. It is easy to use. It has low warping. Warping, I'll explain it in detail in my later slides. The warping basically is nothing but the edges of your print curved up. So that is called as warping. So we want the print to be flat, but sometimes what happens due to the contraction, as it is heating, so there will be contraction and expansion. So when it cools down, the edges contract. So that's why what happens, the edges come upwards, so it bends upward. So that is called as warping. So there are methods to avoid that also. I'll explain that in my next video. It is biodegradable, yes. Low toxicity, so obviously you can't eat that. It will definitely affect you. But it is the fumes which are produced due to this plastic burning. You know, if you burn the normal plastic, there are very high toxic fumes are there. But in 3D printing, the quantity of that is it is very low. So it is very low toxicity. Wide range of colors can be implemented in PLA. The finishing is very good. It is low cost, so around 1 kg of PLA, standard PLA, which is of white color, it goes for around 800 rupees. The dimensional accuracy is very good. It is odorless. There will be no odor from the object which is made. It is versatile. So these are the few of the advantages of our PLA material. Next, we'll move toward the some of the disadvantages of PLA. So it is low temperature resistance. So as you know, the standard PLA melts around 200 degrees Celsius. But even if the product is ready, and if you put some blower or if there is lots of heat around, it will tend to bend, or it will become flexible, or it will change its shape. So it is susceptible to temperature. It is brittle. So if I bend, it will easily break. it has limited strength. Again, it is corresponding to brittle only, so it is limited strength. So that's why we are moving towards the next of that is ABS material, carbon fiber. So if you want strong material, you opt for that. Then it is sensitive to moisture. So this is the important parameter you need to know. So what happens if you are not using the 3D printing, the filament should be kept in an airtight container, because what happens, this material attracts lot of moisture. So what will happen if there is moisture into your filament? So when it is heating, when you are printing, the nozzle temperature is around 200 degrees Celsius, and if the filament has moisture, so when it is coming out of the filament, out of the nozzle, it is a very high temperature. So what will happen, the moisture is nothing but the water content in that filament will tend to evaporate. It will convert it into gas immediately, vapors immediately. So what will happen, it will heat up, it will break the filament. So instantaneous change in the temperature, the moisture will evaporate, it will break the filament, and there will be threads from the filament. So it will totally hamper your entire output. So to reduce this moisture, you have to keep it in airtight containers. So there are some dehydration boxes available for the 3D printer. So when we are not using, or when we are using also, you can put our entire filament into the dehydration box, which maintains the temperature. Next is limited chemical resistance. So obviously the material, it is resistant to chemicals. So you can put the chemicals also, not a big deal. Lifespan, as it is biodegradable, as I have mentioned earlier. So obviously it will not last long. So it will have some lifespan. After that, it will start degrading. Difficult with support. So difficulty with support. So you have lots of supports there for a structure to be made. So the supports have to be removed, which sometimes cause a lot of problem. So if you have much complex geometries, so the printability will be less. Then can clog printer nozzles. So the thing is that while removing the filament, you have to be very careful. You have to push the filament down, then you have to remove up. So it can clog the printer's nozzles. And if the printer nozzle gets clogged, then you have to remove the entire thing. You have to open it. So it's a lot of technical thing which I have to go through that. So to avoid that, you have to always keep the nozzles clean. The filament loading, unloading should be done properly. So limited availability of high performance variants, like again the complex geometries are there, so the availability is quite low. Next, we'll study about the ABS. So this is the advanced version of PLA. It is much stronger than PLA. The temperature resistance is quite good. So if you want to make a strong objects, accurate objects, the finishing should be good. So you have to go to this material. But the thing is that for printing this material, that environment should be contained. There should be no AC or fans in the room, as the temperature of this melting point is quite high, around 250 degrees Celsius it is. And it cools down instantaneously. So you have to control the environment temperature also. So that's why most of the companies, or we are using PLA, because PLA can be printed in AC room, or the fans are there. There is no need of closure for PLA, but for ABS you have to keep many restrictions. You have to maintain the temperature also. So ABS, the long form is acronyl butadiene citrine. So ABS is a common thermoplastic. Again, it is a type of a thermoplastic material used in 3D printing. It is known for its strength, durability, and versatility. And it is often used to create sturdy and long-lasting objects. So the same object you can see, which is printed using PLA, and it is printed using ABS. So you can see the accuracy, the polishing, finishing is quite good. And again, it is sturdy. It will be quite stronger. It will be temperature resistant. So temperature resistance, it will have high temperature resistance. So 250 degrees Celsius, as I mentioned earlier. So if you want to make strong, sturdy objects, you have to go for ABS. So this is just a diagram comparing the strength, stiffness, durability for the PLA and the ABS. So PLA, you have the strength, stiffness, and part quality, it is focusing. And for ABS, the strength, stiffness, and durability, it is much durable. Again, it is heat resistant. So the part which is highlighted, which is focusing this part, and for PLA only these parts are highlighted. So you can see the graph, these parts are high. So quality is good, strength is good, stiffness, it is there stiffness, but durability, heat resistance and chemical resistance is very low. For ABS again, part quality, strength, stiffness, durability, heat resistance is there. Moving forward, the features of ABS contain again the same thing: high strength, good temperature resistance, flexibility, smooth surface finish. You will have chemical resistance is there, the good adhesion layers, so the sticking of the layers is very good, easy to machine and post process, versatile, compatibility with support materials, so you can use different types of support materials also. The availability is quite good. So both PLA and ABS availability is quite good. So these are the few strongest 3D printer materials which we can use. So starting from the basic PLA to the titanium, anything we can print using 3D printer. So carbon fiber is one of the strongest material which can be for 3D printing. We can use for 3D printing. So these are some propellers are made, gears, parts, anything we can make using carbon fiber, but not a basic 3D printer. You will require a 3D printer with high temperature, as carbon fiber melts at high temperature. So we require printers which are compatible with that. So not all materials can be printed in the same printer. You have to use different types of printer. The compatibility is different. And then polycarbonate is one type of, again, it is a transparent material. You can make like this, you can use the bulbs, and you can create this object. Transparent or translucent objects can be made using polycarbonate. Ultem polyethermide, again, so Ultem is basically a brand name for PI. So PI is the material, again a strongest material. Stainless steel, as you know, so any part, body parts, or if any part is fractured or the skull, anything can be designed using the stainless steel material. Titanium, here you can see the skull is damaged, so this part of the skull is 3D printed. So technically in this traditional method, what they are doing, they are molding according to the skull shape, and then they are fitting the object if the skull is damaged or the part is broken. So they are molding, but that is not accurate. But in 3D printing, you can scan the face of the patient, and then you can perfectly design the part which has to be fitted on its skull, and that can be printed. So it is accurate and it can be perfectly done. Again, some of the gears, parts, the rib cages, everything can be 3D printed using titanium material. Inconel is, again, it is used in machines. So it is again a alloy. It is highly resistant to corrosion and high temperatures. Then why we require support materials? So now, till now, you might know the uses of the support materials. So again, it prevents deformation. So you require support materials, prevent drooping. It improves the print quality. Support material follow the complex creation of geometry. So here you can see the shape of a dog is designed, and these are all the support materials required to make it happen. Here also the support material. Here the thing is that two different types of materials goes into the 3D printer. One is for the object, so this is for the object, and this is for the support material. And this type of support materials is water soluble. So you just have to get this and put inside the water. So this water soluble 3D printer material will get dissolved in that. It will get removed and only the object will be there. So this is one of the easiest type of support removal methods which most of the people are using.